So, as a matter of recap of the past episodes, we had this problem where we had a loan, and that loan was recorded first using the amount of net proceeds that we have received, assuming, of course, the foot of baby G. So baby G is the main character in that problem. So in solving problems, we always assume who's the main character in the problem, okay? So the net proceeds, by the way, is again 1,862,774. And since it is smaller than the agreed principal to be paid, we have computed the new effective rate, which is 14%. And because of that, we continued completing the timeline already. So we have 1,862,774 times 1.14 or 114%, the liability balance became 2,123,562 after 1 year. Now, we deducted the first interest payment and we got an updated liability balance of 1,883,562. So, after that, since we are in financial difficulty, one half of this has been paid off not using the cash but using a land owned by baby G. Okay? And 1/4 of this liability was paid with shares, which is why there are two deductions in here. And because of these two deductions, the remaining balance became 470,890.5, which is 1/4 of the original liability. Now, we have computed again a new present value of the debt because there is already a new payment term, right? So, actually, the principal to be paid is only 500,000. Because, again, 3/4 has already been paid. And the interest is now 10% or 50,000. That's 500,000 times 10%. It is because we modified the terms from 12% to 10% and the creditor agreed. So, again, that was originally 12%. Anyways, the present value that we have computed after modifying the terms, specifically the interest to be paid, totaled 441,726 using, of course, the old effective rate of 14%. So we have compared these two balances, the new and the old balances. And then we got a difference of 29,164.50, which is, in percentage, that is less than 10% based on the old liability. So because of that, we concluded that there is no substantial modification and this old balance will be carried forward. Okay? However, the problem is we need to find another rate to be applied in these new payment terms because it's very clear that we cannot use 14% already. Because if we do that, it will result to this. We wanted to have a rate that will result to this old liability balance. Okay? So how do we do that? Let's talk about that after this. So, to find the new effective rate, we need to do the trial and error. And of course, to lessen the time needed in getting the effective rate, I will use this 14% and its resulting present value here as one of the two rates needed to be tried on in order to have an interpolation. Okay? So we need the second rate. Now, for the second rate, I will try using 12%. So 500,000 principal times 1.12 raised to the power of -4. And as to interest, we have 50,000 times 1 minus 1.12 raised to the power of -4 over 0.12. Now, the present value factor for this is 0.63552 times 500,000 equals 317,760. And for this here, we have a PV factor of 3.03735 times 50,000, and we will get a present value for interest of 151,868. So next is, Let's get the sum of these two, and we will get 469,628, which is very near to the value that we are looking for. So, let's use this as the second term. So, we need to use both the rate and the resulting present value amounts. Okay? So, because of that, we are ready to do the interpolation. And again, we are trying to find the x, as in the effective rate that should be used to get the present value that we desired, which is 470,890.50. So, how do we do that? Of course, we start with the brackets. So, this smaller brackets means this one minus this one, and also on the other side, this one minus this one. And these longer brackets means this minus this, and on the other side, this minus this. Now, since we will not find the difference of this 14 minus x, let's call it D. Again, D stands for 14 minus x. So, after those, or after that, let's solve. 14 minus 12 is 2. So, let's have that as the numerator. And then, 14 minus x is again D. So, let's make it the denominator. Now, in the opposite side, let's do the same. This minus this equals negative 27,902. And this minus this equals negative 29,164.5. So let's make that the denominator. So the next step is the cross multiplication. So negative 29,164.5 times 2 equals negative 58,329. So take note that I used 2 as a whole number and not the 2% or its decimal form, which is 0.02. So I did that to make the computations less confusing. Okay? But if you want to, you can use the decimal of 2% or 0.02, and you will still arrive at the same answer if done correctly. Okay? So, moving forward, D times negative 27,902 is negative 27,902D. Now, to get the value of D, we need to divide both sides with negative 27,902. So, this will be cancelled. And then, negative 58,329 divided by 27,902 negative. So, that would make the D 2.090495. Now, this D, if you remembered, it's 14 minus x, right? So, let's put it here. Now, we need to eliminate this 14 here so that the negative x will be left alone. So, how to do that? Of course, by deducting 14 from both sides of the equation. And I know that you have other options, like directly transposing the 14 to the left side of the equation, but you need to change this to negative 14. Actually, it's up to you. So this one here, I'm using the elimination method. So even if you use elimination method or transposition method, it will have the same result. So this here will be cancelled. And this here, 2.090495 minus 14 will become negative 11,909,505. So, negative x is equals negative 11,909,505. So, to make these two positive, we need to divide them both by negative 1. And we will have x is equivalent to 11.909505% or 11.91%. And that's the effective rate that we are looking for. Or if it's not, then I'm sure that this number is very near to the correct rate. Okay? So, since we have this already, the question is, what will happen next? So, that would be on the next episode. So, stay tuned.